Hi, Chris Kuzmal. We're continuing. Now we're looking at the code to see what the heapify operation code looks like. The heapify operation code is right here. It's on line 61 in our heap class. And heapify on line 61 takes an integer I. So that's going to be the index at which we're going to establish that the heap property is true. Now then, the index of the smallest of the three nodes at location I, the location left of I, and location right of I, whichever one of those has the index of the smallest value is the one of interest. That should be the one that becomes the index of the root. So we do that now. We've poorly named this. We've made index of largest equal to get index of smallest. Oh my God, what a terrible naming choice I did. So I need to change that index of largest to index of smallest. So keeping that in mind, if the index of that most extreme element is indeed the root's value, which is I, then we're done. Everything is great. Otherwise, we need to swap that index of the most extreme element with I, and then replace the index of the former root with that index of that most extreme element, and proceed to heapify at that index of what used to be the root, but which has now been shifted down to one of the children, in our example, the left child. All that's required for you to know now is how get index of smallest works. Here's get index of smallest. It takes any three integers which represent indices in our heap A. First, it checks to see whether or not each of them is indeed in the range we want. We're assuming that they're positive. I suppose I should have a line of code that checks to see whether or not they go negative, because I could get an error otherwise. I then extract the value at I, the value at j, and the value at k in the next three lines. So these 6 lines are intimidating, but all they do is extract the values corresponding to the indices at I, j, and k. And then we have a little bit of logic. We compare the value at I to the value at j. If the compare to gives us something less than 0, and the compare to for the value of I, the value of k gives value less than 0, that means that index I has the smallest value, okay? And so this double if statement tells us that, in fact, I is the smallest index. Well, if I isn't the smallest index, we just have to determine whether or not it's j or k. So I could have skipped a comparison with I here. I could have just checked, because we already know that v of j dot compare to v of I is less than 0. So this line of code, the line of code on 82, is redundant, but it's going to be correct. The code will run correctly. Line 83 checks to see whether or not the index, the value at j is less than the value at k, and if it is, we return the index j. And of course, if none of the above works, or none of the above does what we expect, that's neither of those are correct. It's neither work or correct. That's the question. The question is which index is that of the smallest value. If the index I is not that of the smallest value, and the index j is not that of the smallest value, then it means we have to return index k, and that's what happens on line 87. Now then, you'll notice though on line 70, what we do is if we have something that's out of bounds, we return the index of the smallest of the other two. There's 2 arguments to get index of smallest on these 3 invocations, while this get index of smallest has 3 arguments. Well, that's perfectly legal and fine in Java. That's what happens. We skip past this swap code, which swaps the values. That's something that you hopefully can figure out what's going on. And you get an index of smallest is the exact same logic, kind of logic, as get index of the other get index of smallest. It's just that it has 2 indices instead of 1, and so that code does the same thing. There's a little bit of fancy question mark bit here, which just checks to see whether or not what we're going to do if I is bigger than the size, and if j is bigger than the size as well, then what are we going to return? We're going to return 0. Otherwise, we'll return j. So that's a summary of, that's actually a detailed description of how get index of smallest works, how heapify works, which includes getting index of smallest. And we have a coding failure, poor style, in terms of our naming of this variable. Index of largest should be index of smallest. And so I'll make that change for future videos.